everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem: solve d cube minus 4d square into y equals to 5. Solution: given differential equation, d cube minus 4d square into y equals to 5, which is in operator form. F of d into y equals to q, where f of d equals to, compare these two equations to get f of d, which is d cube minus 4d square, and q equals to 5. You can just write this 5 as 5 into e power 0 into some x, right? Now, we'll find the solution to the given equation, or the solution is given by yc complementary function plus particular integral. We'll find complementary function using auxiliary equation of f of d into y equals to 0. We'll not consider the non-homogeneous equation. We'll just put the RHS part to 0 and we'll consider homogeneous equation to find the auxiliary equation, that is to find complementary function using auxiliary equation. And we'll find yp using 1 by f of d into q. Okay, fine. Now let's see what is order and degree of the given equation. So we know that differential operator is d equals to dy dx. Then you can write the above equation as d cube y minus 4d square y equals to 5. Then you'll get d cube y by dx cube minus 4 d square y by dx square equals to y. So here the highest derivative is d cube y by dx cube. So our order will be 3. And the highest power of highest derivative. Here we have only highest derivative, right? We have d cube y by dx cube as a highest derivative, and we don't have another d cube y by dx cube. So the highest power of this derivative is 1 itself. Okay, 1 only. So the degree is 1. Now coming to the problem, let's find complementary function using the auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, you'll get f of m by replacing the differential operator d by m. Then you'll get f of m equals to m cube minus 4m square. Now the auxiliary equation will be m cube minus 4m square equals to 0, right? Since you're having m square in both the terms, so let's take m square common. Then you'll get m square times m minus 4 equals to 0. Now we need to find roots, right? So from this we'll get, you're having two m's, right? You'll get m into m, and you can just write this as this, m minus 4. From this you'll get roots m equals to 0, 1m equals to 0, 1m equals to 0, and from m minus 1, just equate this factor to 0, you'll get m equals to 4, right? Equate everything to 0. Then you will get m equals to 0, m equals to 0, and if you equate m minus 4 to 0, you'll get m equals to 4, right? Then here two roots are equal and one is distinct, right? Therefore, m equals to 0, 0, 4 are the roots of f of m equals to 0, the auxiliary equation, right? Which are equal and distinct, right? The first two roots are equal and third root is distinct. Say m1 equals to m2 and this is equal. Both are equal roots and m3 is a distinct root. If we have two equal roots and one distinct root, then the solution is given by y equals to c1 plus c2x into e power m1x. Since m1 equals to m2, so you will write 0 into x plus for the distinct root, take another constant c3 into e power the constant, the root, distinct root into x. Okay, complementary function will be. So complementary function will be yc equals to c1 plus c2x into e power equal root into x plus for distinct root constant into e power distinct root into x. Since we know that 0 into x is 0, then you'll get e power 0 which is equals to 1, right? Or we can write two more steps. c1 plus c2x into e power 0 into x is 0 plus c3 e power 4x which is equals to c1 plus c2x into, since e power 0 is 1, then you will get plus c3 e power 4x which is equals to c1 plus c2x plus c3 e power 4x. Therefore, complementary function is y is equals to c1 plus c2x into c3 e power 4x, right? Now let's find particular integral. Particular integral is given by y equals to 1 by f of d into q, which is equals to 1 by, we have f of d cube minus 4d square into q is 5. You can just write 5 as 5 into e power some 0 into x, right? Since e power 0 into x is e power 0 which is equals to 1, right? Again you'll get 5 here. 5 into e power 0 into x is 5 into 1 which is 5. Now, you can write this as 5 into 1 by d cube minus 4d square into e power 0 into x, right? Now, let's find, we are having f of d equals to d cube minus 4d square, right? Now, let's see what we'll get for d equals to 0. Okay, for some f of 0, you'll get d 0 cube minus 4 into 0 square which is equals to 0, right? Since f of 0 equals to 0, so what we'll do, we'll write 1x and find the derivative of this, that is f dash of d. We'll find f dash of d. Since f of 0 is 0, you can't substitute or replace d by 0. Okay, you'll get the denominator as 0, then 1 by 0 will be infinity. So we'll not put 0 in the place of d and we'll find f dash of d. Okay, but write f dash of d into e power 0x which is equals to 5 into x into f dash of d is 3d square minus 4. 4 2s are 6. Sorry, 4 2s are 8 into d, right? Or we'll write clearly 3d square minus 4 into derivative of d square is 2d, which is equals to 3d square. 4 2s are 8 into d. Okay, now let's see what happens if we replace d by 0. You'll get 0 minus 0, again you'll get 0, since f dash of 0 is equals to 0. So what we have to do? We have to find again derivative of f dash of d. Okay, let's write one more step here. 1 by write f dash of d, that is 3d square minus 4 2s are 8 into d into e power 0x, since f dash of 0 equals to 0. So we need to write x into 1x into 1 by find derivative of f dash of d. We need to find f double dash of d simply. Okay, we'll find f, that is derivative of f dash of d simply. Then you'll get 3 into derivative of d square is 2d and derivative of 8d is minus 8, which is equals to 3 2s are 6d minus 8. Okay, f double dash of d into e power ax. So now we are having 5 x into x square into 1 by f double dash of d, which is 6d minus 8 into e power ax. Now we need to check f double dash of 0, which is equals to 3 2s are 6. Here we are having, right, 6 into 0 minus 8 equals to 0 minus 8, which is equals to minus 8, and it is not equals to 0. Okay, since f double dash of 0 is not equals to 0, so we can substitute f double dash of 0, which is equals to 5x square into 1 by f double dash of 0 is minus 8. This is 0, not a, okay? 0, 0, 0, 0, 0. Then we'll get minus 5 by 8 into x square e power 0 into x, which is equals to minus 5 by 8 into x square, since e power 0 into x is e power 0 into x is 0, e power 0 is 1, right? This value is 1. So you can just write this as minus 5 by 8 x square, or minus 5 by 8 into x square. Okay, so yp is therefore yp equals to minus 5 by 8 into x square. Therefore, the general solution is y equals to yc plus yp complementary function plus particular integral, which is equals to complementary function c1 plus c2x plus c3 e power 4x, and yp is minus 5 by 8 into x square, right? Therefore y equals to c1 plus c2x plus c3 e power 4x minus 5 by 8 into x square is the required solution. So let's see how to find yp in more detail. We have yp equals to 1 by f of d into e power some x, right? So we are talking about q equals to e power ax form, where a is a real number in this case only. Okay, so if now we have to find f of a. If f of a is not equals to 0, then you can substitute f of a in the denominator. That is, you can replace d by a. Then this will be your yp. Okay, if f of a is not equals to 0, if f of a is equals to 0, if f of a not equals to 0, you will get yp. What happens if f of a equals to 0? Then you need to find f dash of d, right? Again, substitute f dash of a, that is, substitute d equals to a. If f dash of a is not equals to 0, okay, substitute f dash of a. If f dash of a is not equals to 0, then your yp will be equals to x into 1 by f dash of a into e power ax. Okay, you'll write 1x into 1 by f dash of d. Okay, or okay, simply you'll replace d by a if f dash of a is not equals to 0. We should always get the denominator not equals to d 0 to substitute the value of a, or after replacing a in some function, you need to get not equals to 0. If it is equals to 0, then you'll find the derivative. Okay, so if f dash of a equals to 0, if f dash of a is equals to 0, then you'll find f double dash of d, and you can write yp as, you are already having 1x, right? Put another x into 1 by, find f double dash of d into e power ax. If f double dash of a not equals to 0, then our yp will be x square into 1 by f double dash of a into e power ax. Okay, if not, you need to find f triple dash of d. Okay, if f double dash of a is equals to 0, then you'll find f triple dash of d, and you'll include one more x in yp, then you'll get x cube into 1 by f triple dash of x. Since you're having x into x square, you'll include one more x, and you'll find f triple dash of d into e power ax. Okay, and so on. So this is the actual procedure to find yp. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.